Now we are moving to the chapter inverse graphs. An inverse graph is basically a reflection on the line y equals to x. Okay. For instance, if I want to find the inverse graph of this circle there, say, so the circle is our original graph. And the inverse graph, to find the inverse graph, I need to reflect the circle on the line y equals to x. So it will be, okay, the inverse graph will be somewhere there. Okay, and this is basically an inverse graph. To simplify it, I can say, well, just let me write down the definition here. An inverse graph of an original graph is a reflection of the original graph. On the line y equals to x. Okay. 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 Now I do an example for you. Okay. So, for example, if someone asks me to find the inverse graph of y equals to x squared, and the domain is x belongs to R. Okay. Now, what do I do is to draw the original graph on my axis first. I have y, x, so my graph should look like, like that. Okay. Yes. Y equals to x squared, and the domain is x belongs to R. Okay. Then what I do is I draw the line y equals to x, and I have to reflect the original graph on this line. So I should have a graph looks like that. Now the red graph is the inverse graph. Okay. Okay. In math method, you not only have to draw the inverse graph, but in most of the cases you have to you have to state the equation, the mathematical equation of the inverse graph. Okay, now let me show you how to do it. Okay, okay, let's go back to the previous example. Y equals to x squared, and x belong to R for the domain. Okay, let's find the equation of the inverse graph. So, in order to do that, we have to label the domain of the graph, also the range of the graph. Y belongs to square bracket 0 to positive infinity. Okay, well, just like the original graph, the domain of the original graph and the range of the original graph. Okay, now to find inverse, to find the inverse equations, what I have to do is to exchange x and y, okay, to make the word is to interchange change x and y. Okay, so x belongs to x changed to y, and y is changed to x. Okay, in this. Okay, so the inverse function will be x equals to y squared, and the domain in the original function will become to the range. Okay, x belongs to R will change to y belongs to R. So similarly, the range of the original function would become the domain of the inverse graph. So I would have x belongs to square bracket 0 to positive infinity. Okay, now this is the mathematical equation of the inverse function. Okay, just equation of inverse graph here. Okay, now let's rearrange the equation. So I will have y squared equals to x, and y would be positive or minus square root of x, and the domain of the inverse graph will be x belongs to 0 to positive infinity. Okay, as we can say, because we have y equals to plus or minus square root of x, we actually have two equations. Okay, and the domain is the same. So okay, Okay, now uh, let me draw those two equations on axis just to show you guys how does it work. Okay, so okay, from your formula sheet on standard graph, you should know the shape of the equation y equals to square root of x. If you don't have it, you can download it from our website. There is a PDF file of all the standard graph you have to know in math method. Okay. Square root of x would have this shape. Okay. Similarly, y equals to minus square root of x would be just a reflection of the standard graph on the x-axis. Okay, so just label y equals to square root of x, and the domain is square bracket x belongs to square bracket 0 to infinity. Okay, and I would have the other one like this: y equals to minus square root of x, and the domain is the same. Okay. Okay. Let's let's compare this graph as the graph we have here. Okay, in this in here, the red graph is the graph we draw from a reflection on the line y equals to x, and as you can see, they are similar graphs. Okay, say here, they are similar graphs. So, okay, uh, what I can say is to find the mathematical equation of the inverse graph, just just interchange x and y. Okay, and also with the domain and the range. Okay, after the interchange, the important thing is the domain of the original graph would becomes the range of the inverse graph. However, the the range of the original graph is the domain of the inverse graph. And remember our rules on sketching graphs, we always have to label the domain when we sketch a graph. So uh, it's very important to know that. So the range of original graph would be the domain of inverse graph. Okay, so just make a note. Okay,